This is part 2 of CIS27 Unit 5 lecture. To pick up where we left off, we're going to talk about cloud, and there are different types of cloud, and there are different services that are available for cloud technology. And so the cloud is just a type of service that we would use to be able to host applications or accommodate network needs using a third-party vendor like AWS, Google, Microsoft, just to name a few that would be the main giant in cloud technology. So in the cloud systems, you would have switches, routers, servers, and the roles for appropriate servers that would be aligned with whatever the company would need. So basically, we're leasing the systems and the servers in order to accommodate our business operation. So there are two types of cloud services, the two type of clouds that will be on-premise and hosted. And on-premise, that's usually owned by the company. It's operated and maintained by the company. And for the hosted, that will be something that we lease or rent from another organization like AWS, Google, Microsoft. So within that, we would see there are three types of services. Software as a service, in which software application that we need to provide to the user over the network, the internet, like some of your web apps. Platform as a service, your the PaaS, that would provide the pre-configured computing platform, operating system and application for the user, so they would be able to connect to their platform in order to do the work. And then infrastructure as a service, that would be network equipment that needs to be required for the operations. And organizations that use infrastructure as a service, it's really aimed for the organization that cannot afford the server, the hardware, or they cannot manage or maintain the hardware and the server. So it would be very few resources that they would need in order to incorporate cloud technology in their business operation. And the responsibility as far as security for the cloud, maintenance, and the security responsibility would relate to the service. For SaaS, the software as a service, the provider assume the primary security responsibility, which is up to 90%, but it also depends on the contract. Platform as a service, the cloud service provider and customer assume 50% of the responsibility for the maintenance and security, and also that could be depending on the separate contract. So not all contracts will be stated at 50% for the responsibility with the customer or the CSP, but in most cases, this is what we commonly see. Infrastructure as a service, the cloud service provider would assume 25% of the responsibility in security and maintenance, and then the customer would be 75%. So in some cases that would be higher or lower. Like I said, it depends on the contract. Cloud Access Security Broker, CASB, is a tool that we would use to coordinate the services and monitor the traffic and enforce the policy that is needed for the cloud. And Cloud Access Security Broker can come in different flavors, as we would have different cloud provider that use different cloud technology. So for the next question, it asks you about the cloud products and how do you secure cloud. So for the types, we can say that there are two types: the on-premise and the lease through the cloud service provider. The service, we would have three types of services: infrastructure as a service, platform as a service, and software as a service. And how would we secure the cloud? We would use Cloud Access Security Broker to be able to accommodate monitoring, security enforcement and to make sure that we use it to check the status of our system. It asks which cloud deployment model is suitable for the enterprise. And we can revert back to the notes starting with page 3 and going into page 4. It talks about cloud deployment model. So the public model provide the services to anyone that's willing to pay, and this is what you normally see with your general consumer for cloud services. The private is where an organization would set up a specific type of cloud environment for the need of the organization. And the community, you would see that shared cloud resources being offered, and hybrid is where we would have a combination of two. And from what we see is that enterprise environment, you might have a hybrid in which you could have a private setup with additional type of model that would be implemented, because in enterprise scale, we would have a mix of different needs for our system and how to secure those systems. So for the next question, for question 13, it asks for a cloud deployment model. Which cloud deployment model would be suitable for enterprise? And we can put down that it would be hybrid enterprise, where we would have a combination of the two, mainly private with another option. Then in the next part, it talks about mobile devices and security. So as you know, there are a lot of different type of mobile devices being implemented and used in a network environment for businesses. And all of these devices would connect to the network, and that would impose some risk in storage or communication settings. So it could introduce malware or have files that would be extracted from the organization and stored on the mobile devices if it's not controlled properly. And communication settings, especially with the wireless and Bluetooth, we wanted to make sure that we implement the security measures to protect communication and storage, such as we would scan to scan files and downloads. We would make sure that encryptions is properly set for specific wireless communication settings. So now mobile devices can also have GPS services in which that would check the location of the device or the individual that's using that device. So for mobile security, we need to think about how we would be able to protect, number one, the network systems that are existing for the company. Number two, to be able to protect the privacy of the user when using the system. And number three, to protect the mobile system itself through setting up logical security and administering the actual devices with our policy and procedures. And question 14 asks, how do you implement bring your own device security in a business? We should implement the scan for malware in the device when that device is attached to the network. We can control file storage with permissions and privileges and user rights. We can control sensitive data by using encryption and encrypting the transmission of such data over the web to prevent data leakage. And some of this also ties back to permission control and how the user access the data. So implementing other procedures in authentication and access management would be useful for the bring your own device security. And here you can see the different models for mobile device implementation in a network. You would have a corporate owned, where the company would purchase the device for the employees. You would have COPE, which is corporate owned, personally enabled, where employees are able to use the device freely as their own device, but the device is provided by the corporate or the business. Bring your own device, where employees provide their own device for business functions. CYOD is choose your own device, where employees purchase from the recommended list, and the list would contain the allowable device, so that way we can manage the control with those devices in such operating system or communication setup. VDI would be another model where virtual desktop infrastructure is implemented, which allow the user to access from mobile devices. So these are the models that you commonly see for business implementation. Now for the connection, mobile device can be connecting to the cell tower using service provider like AT&T, Verizon, T-Mobile, or they could be connecting to wireless access point. And with that, we need to look at the encryption and the wireless connection issues. The mobile device could be connecting to satellite or use Bluetooth, and satellite uses line to sight. So we want to make sure that we would set up satellite connection for the satellite that would be available. And satellite connection tend to be unstable. It has a lot of impacting factor, such as line of sight, time of day, etc. So satellite communication would be something that we would implement more of a backup option. Bluetooth, it uses ad hoc device to device, and so authenticating on Bluetooth and pairing is important. For a shorter distance range, we want to make sure that the signal is available, and how the pairing of the devices needs to be established securely. So changing the default pairing passcode is also important. MFC is used for peer-to-peer in one device to another device, and this could be used for file transfer, remote control, a lot of different areas using NFC. And signal can be intercepted in using some of these technologies, so we want to make sure that we protect the signal and how the device is setting up peer-to-peer connection. And ANT is used for wireless protocol to send data to mobile device applications, and you would see this being supplemented for some of the type of systems, such as Apple systems, in which you would use specific protocol to be able to do AirDrop, etc. Infrared is used for line to sight, for door access, or for managing inventory. And infrared would require a signal reader, in which that the risk behind this would be that sometimes signal can be intercepted, and sometimes the reader can also have malfunctionality. So what we want to make sure is we want to implement the appropriate system and the connection means that with security measure, so that way we will protect the system. And USB is a common type of connection, and the user would bring in their USB devices, their storage, to be able to attach to the computer, and that could introduce risk, because they could bring in malware, they could bring in Trojan that would open up avenue for unauthorized user to access the system. So we want to limit the USB use as much as possible. So for managing mobile devices, we want to restrict applications and the privilege, the permissions that come with the application to access other part of the device, like camera, speaker, and microphone. We want to also disable the application that we don't need on the device, or uninstall them. Use encryption for full device to prevent data loss. And for storage segmentation, we can reduce data loss risk by segmenting the storage for specific data and use permission to control the data. Content management, we can implement authentication to enforce data access. And then we can use container and encrypt the container to enforce the protection for the content inside the container, like folders, objects within our shared drive. Password and pins that can be implemented and supported by policy, and that ties back to authentication for access on some of these devices. Biometrics can be also used for authentication. So we wanted to also think about multi-factor authentication in such sense. Screen lock to protect more privacy in case the device is being accessed by unauthorized users, so we can use screen lock with PIN or password or biometrics. Remote wipe allows us to wipe the data when the device is lost or stolen, and that would require additional services to be set up with service provider, so that way we can remotely wipe the data and or set up sync for data for cloud in case there needs to be a backup. Geolocation, geofencing allow us to define the physical boundary of the device access, and in the case where the device is lost, we're able to locate it. So the notes give us information on how to manage the mobile device, including push notification to send messages to the user about updating policy, about security settings, reminder for the user to implement certain practice for safety precaution. Now, when we use mobile device, we should monitor the mobile device. We can use NAC or software tool to monitor the state of the mobile device. Also check health when that mobile device is connecting to the network. Scan for malware. We can also push firmware updates to all the connected mobile device or schedule updates once we test it. We can prevent the user from using jailbreaking device, because once the device is jailbroken, number one, it voided the warranty on the device. Number two, it elevate the privilege of that device into the higher administration type of access. So we want to make sure that the device is not jailbroken when it's being used. Validating apps, making sure that the apps are authorized, and we can control that with policy and application server. And then using the tools to make sure that we protect our system and prevent unauthorized access and connection to different access point or connecting from one device to another device. Now, mobile device sometimes would include embedded systems. So in embedded system, you would see that there would be patch management and fixes that would need to require. We need to update firmware. We need to patch the applications. We need to also update OS on these embedded systems. So the example for the embedded system would be your Internet of Things, such as smart thermostat, wearable technology. A lot of the smart device that you see today would fall under the category for the embedded system. And all of these systems require network connectivity. So we want to make sure that we monitor the network activities and also the policies. Industrial control systems, ICS, we should use the network intrusion prevention system to block unwanted traffic. And industrial control systems sometimes would be needed in various industrial area for manufacturing, farming, transportation means, etc. So the ICS is important, and we can, because it's connected to the network, we can use an IPS to block traffic and prevent attacks. And so real-time operating system allow us to react to real time, where it ensures the receipt and the process materials for at the specific time. So some of the real-time operating system that's being implemented, we want to make sure that it is processing what's required in specific time. HVAC, as you've probably heard from the target attack, HVAC system is also connected to our network environment, but we want to make sure that we have protection for the connection. So we need to monitor, we need to block and filter along with maintaining the environment so that way we can use HVAC to maintain the temperature for our systems and in general. And then unmanned aerial vehicles, those are the drones. So we need to think about the type of protocols and the ports that's being used for communication across these drones to control these drones. And for to really drill back to privilege and permissions, we can tie all of this back to the device access control list. We can also use security appliance and software tool to be able to protect some of these systems. So for the next question on number 14, 15, and 16, when you write out the answer, you should think about the embedded system that's using Linux, the mobile devices that are using Linux or could be considered the Internet of Things systems. And also we need to think about how we would prevent data loss in these devices. So for Linux system, the way that you grant permissions would be in following on the bottom of page 5. So the owner would have full control, and this individual would be able to grant permissions to other users and groups. The group, we can grant the permission to a group of members or users, and in the group level, that will be less than the owner who have the complete ownership and full access to the object, such as files and folder. Others, everyone else, would have the apply permission that would be set, and for default, most of the time, if everyone else have access, that would be read. So we wanted to have least privilege and access control for a lot of these devices, files, and folders and objects in our network. And the way Linux permission works is a read permission is equal to 4, the write permission would be equal to 2, and the execute permission would be equal to 1. So when I have read and write, that will be 4 plus 2, which gives me 6. And if I have read and execute, I would have 4 plus 1, which gives me 5. So in order to have the full control, we would have read, write, and execute. So that would be 4 plus 2 plus 1, which gives us a 7. And we would start with the owner permission in the first digit, which could be, so in the case where if you're looking at permission where it says 400, that means that we can have read, and then the rest, the group and the others have 0. So the owner would have read, and the other two would have 0. So for everyone else in that would not have to have access. For Windows permission is a little bit different, where we have read, and execute. So with read and execute, the user can run the program. Write is where the user can create file and subfolder and then modify the existing file, like edit it. Modify is a little bit different than write in that the user can read, execute, write, and delete files. So modify allows the user to delete, compared to write, where they can create new files and change the existing files or folder. So to answer the next question, we can say that The Linux system, you can grant the permission to file1.txt to permit read and write. So the read is 4, the write is 2. So read write would give us 6. Now to prevent data loss in organization, let's go back to the notes. And to prevent data loss, we would think about how we use removable media through USB port or through a card reader. Make sure that we prohibit the use of removable media or have high limitation in the use of removable media. Then we have data exfiltration, where we would have unauthorized transfer of data outside of the organization. We want to prevent that. So we don't want the user to transfer data outside of the organization. So if they're connecting their mobile devices to the network, we want to set up the zone where it would tie to the geographic location of that mobile device. And as the user leave the organization, it would disconnect from that zone and be able to implement encryption or protection to that data where the user cannot take the data outside of the business. We can implement cloud-based filtering for sensitive data such as personal healthcare information or identifiable information that is private to the user or the customer. So we can set up filtering sensitive system in email, in access, in storage to make sure that we don't leak the private information outside of our network. So for the next question, we can say that we want to limit removable media, we want to prevent unauthorized transfer of data outside of the organization, and we want to filter sensitive data to protect the sensitive data from leaving the organization. So this concludes all 16 questions for my lecture. I encourage you to read the chapter, and if you have the textbook, you can take the practice tests or review questions at the end. That's going to help you prepare for certifications. And for the next video, I will put up a lab video, so please watch my lab video.